Hello, and welcome to What's New and What's Next in Azure Compute. My name is Drew McDaniel, and I'm a Group Program Manager in the Azure Compute team. My team is responsible for our virtual machine scale sets, and also cloud services workload on Azure. Today, we'll be talking about some of the functionality that we're releasing this week at Ignite, as well as some of the functionality that's recently been released that we think will help you be successful in running your infrastructure on Azure virtual machines. We will cover some of the functionality that's been released recently on dedicated hosts and how we've enhanced that functionality. We'll talk about patching of virtual machines and what we're doing to give you more control of the patching of those instances, how you can control when the infrastructure is updated through our maintenance control functionality, and then how you can get more out of our Azure VM spot instances that allow you to lower your cost of ownership while running these heavily discounted instances, but with more control. And finally, as I mentioned, we will wrap up with some of the key functionality that's been recently released. And so we will hit these four areas. Specifically, we will cover the new capabilities for security and compliance around dedicated hosts and patching, availability and resiliency through the maintenance control, and cost effectiveness through the new dashboards and functionality that will be released for spot virtual machines. And then finally, we'll wrap up with a summary of some of the more recent virtual machine sizes that have been made available and what you can do with VM scale sets and some of the functionality we've added there to give you more control through the virtual machine scale sets. So let's start in security and compliance, looking at the dedicated host. Now, Azure Dedicated Host is a functionality that we released earlier this year that allows you to deploy a physical server for one customer's use. You place virtual machines, whether Windows virtual machines or Linux virtual machines, on those dedicated hosts, and then you have a much greater degree of control over those machines. You can control the placement as well as control when updates are made against those dedicated hosts. For example, you also get additional compliance controls. Specifically, this hits for certain compliance requirements where machines are isolated on the physical server from other customers' virtual machines. Now, this is something that we see in some of the government regulations at different information classification levels. And then finally, you can leverage the Azure Hybrid benefit for both Windows Server and SQL Server to lower your cost of ownership of running Windows and SQL together on the dedicated host by the hybrid benefit capabilities that allow you to apply licenses to the physical cores on the server, and then you can have unlimited virtualization rights on top of that. So it can greatly lower the price point for some scenarios. Now, there's two features we'll be talking about in dedicated hosts that are available for preview this week. The first one is a simplified deployment model that allows you to select a group of hosts and deploy the virtual machines into that group of hosts instead of being required to select individual hosts for each virtual machine. That functionality then expands into leveraging virtual machine scale sets on top of dedicated hosts. And so with scale sets, you can again point it at a group of dedicated hosts, and it will automatically deploy those instances onto those hosts. And so you bring together the compliance and requirements and cost savings for dedicated hosts with the scalability functionality that you get in scale sets. And then ongoing, we will continue to add additional machine sizes and SKUs into the dedicated host. Specifically, the next one that will be coming up is the FV2 series running on Cascade Lake-based dedicated hosts for your compute-intensive workloads. So with that, let's take a look at dedicated hosts in action. Here we are in the Azure portal, and we want to show some of the functionality we just talked about for dedicated hosts. So first, we're going to come in and we're going to go to the dedicated host group browse and select add to add a new host group. Select a resource group. I'm going to set the host group name, so host group here. You will note that we're deploying into the early access region. By the time you're watching this video, this will be available in all regions in Azure. You can select the availability zone for the host group, but in this case, we're going to select none, so that it can select any location in this region to deploy the host group. Select the default domain for the host group. In this case, we're going to do 2. And then here's the new option to support automatic placement. So we're going to go ahead and check that for the host group. It's going to do a quick validation of the host group to ensure everything is good, and then create the host group. Now, this host group itself is just a configuration that will be used for additional hosts as they get deployed into it. So it gets created fairly quickly. We now go to the host group, and we have the option to add additional hosts into the host group. As you can see here, initially there's no host in the group. And so we use the add host operation to add a host. So we're going to do what's new host 1. Again, put it into the same region. Should automatically select the host group. And then here we're going to select the family for the type of the host group. Here we're going to do DSv3. As you see, there's multiple types. We're just going to do type 1 for now. But you can mix and match and have different types within the same host group. The first machine we're going to put in default domain 1 and let this go through the create process. Now it's going to deploy the first physical machine into that host group. Because we want to have a couple machines in this demo, let's go back to this host group. And then we're going to deploy a second host into the group. So here, what's new? Host 2. Select the appropriate region. Let's detect the host group. And here again, we're going to put the DSv3 type 1. And now we're going to put the second host into default domain 2. And so this will create the second host for this host group such that we can start deploying. Now, to leverage the host group, we're going to first look at it from a virtual machine standpoint. So we're going to show creating a virtual machine that's going to leverage the host group. So most of this is fairly normal. So we're going to do just give the name for the virtual machine. We're going to configure it as DSv3 type because that's the type of hardware we selected. We're going to go ahead and use the functionality, the new functionality here to use an existing key pair as it queries the key pair. We'll use an existing key that I had created. This is really nice for when creating Linux VMs and using SSH authentication. Then under the advanced, we will see the option to deploy to a host group. And so we're going to select the what's new host group that we had just recently created. And we're going to leverage the VM placement, automatic placement. If we selected no, you then can select which individual host that you're placing the virtual machine on. By saying yes, we'll leverage the new functionality, and the platform will create the VM and then automatically select an appropriate host in that host group to deploy the VM to. So let's run validation and kick off the create. Now, while that is running, we're going to look at a similar process for a VM scale set. Okay, so that is now submitted. Now we're going to look at scale set. And again, let's go ahead and create the scale set. Again, much of it is when using a dedicated host is very much like the normal. Here we're going to create a what's new VMSS. Unfortunately, with VMSS, it does not integrate yet with the new SSH functionality, and so we're going to use a traditional password for the machines instead of doing the cut and paste of an SSH key, but you will see the new functionality coming soon. And then for VMSS, we're going to go to the advanced section again. Here, we're going to set the spreading algorithm to max spreading. Fixed spreading defaults to 5 fault domains. Since we configured the host group with only 2, we'll leverage max spreading that will automatically spread those instances across the host group. And then we're going to select the what's new host group. And for this, we'll go ahead and scale the number of instances. We'll go ahead and set this around 20 instances. And we'll let the VM scale set operation again do the validation and then start the scale set deployment. Now, while this is running, let's go ahead and look at the host group that was created. Now, if we refresh, we'll see that one of the hosts, in this case, host 2, has an instance on here because there's only 31 D2S v3 available. And if we go ahead and look at the host group, we're going to see that there's one VM that was created here, and there's that VM. And in fact, if you look at the VM itself, you will see down here that it shows the host group that's configured in, and then it was automatically placed on host 2. Now, while the scale set's deploying, I had previously set up a host group with a very similar configuration. Here, we've got a host group that is set up. Here, in this case, we use type 2, and we deployed 40 instances of a scale set. And so here, if we look at the various hosts and you look at the instances, you will see the scale set instances spread across both host 1 and 2. So set of scale set instances on the one of the hosts on host 1. And then if we look at host 2, again, you'll see a set of instances there. So it's leveraging this automatic placement functionality to automatically deploy both VMs and scale sets into the dedicated host group. So let's return to the slides and look at some more functionality to maintain very high levels of security and compliance. So we looked at dedicated hosts and the capabilities there around security and compliance. Also in the area of security, I want to talk about patching and maintaining updates on the virtual machines. Now, on the left side of the slide here, we have our image-based patching. This has existed since last Ignite. It allows for automatic updating when doing image-based patching. This is where you have a set of virtual machines in a scale set, and to update them, you bring in a new image and roll out new instances. And so in this model, it's what's also called immutable infrastructure by some customers. You can update based on platform images, or you can update based on custom images, leveraging our shared image gallery. And this is a great model for really large scale in, scale out type applications. But we've also heard from many of you customers that you want to do updates within the virtual machine using patching capabilities built into the operating system, such as Windows Update for Windows virtual machines. So we are announcing this week in preview in VM patching that you're able to do, starting with Windows. And as you see below, we'll continue to add Linux and VM scale sets going forward. But what this will do will automatically update the instances, your VM instances, in a very safe and reliable manner, applying critical and security OS patches. In addition, it'll do this explicitly at off hours within the local data center. And so in the hours of 4 a.m. to 8 a.m., it will do these updates to try and avoid as much impact to your application as possible. Now, the way that we do this and the way that we roll out updates, and this applies both to platform updates as well as the NVM updates, is through a availability first patching model. And so as you can see here, what we do when we have a new update, let's take NVM patching. So Patch Tuesday comes out for Windows, and we're going to start rolling that patch out to a first wave of regions. Now we do this to a subset of the regions, so we're not going to blast this to every virtual machine in all of Azure all at once. Specifically for regions that use our paired region capability, it's only going to update at most one region of that paired region at a time. And then within the region, especially those regions that have availability zones, only one of the 3 availability zones will start that update. And the process will go through, in the case of availability zone, we'll start updating the instances, monitoring the health of that patch, making sure that the patch applies successfully to the bulk of the virtual machines. And as that zone reaches 90% or greater in success of installing that patch, it'll move to the next zone and then finally the third zone. Once a region is updated, it'll start rolling out to other regions. And so we do it first by regions and then zones, and then specifically within your availability set. And so if you're running your Windows virtual machines in an availability set, we will update only one fault domain or update domain of the availability set at a time, so that the update does not take down all of the instances in the availability set at the same time. Again, monitoring for health, monitoring for success. And so you'll see that we do this, and this is actually how we roll out our own internal software, in what we call a safe deployment process, to ensure very, very high availability of all of your machines as we continue to roll out software. And we think that this capability brought into the NVM updates will be greatly appreciated. Next, we want to talk about availability and resiliency. So maintenance control is functionality that is now available in preview. And what this does is allows you, the customer, to have greater control of when we apply updates to the infrastructure that is running your virtual machines. So we just talked about patching, that's the guest operating system, but now we're talking about patching in the software running those virtual machines. Normally, we do this in a manner, again, following that safe deployment processes that I just mentioned, in a way to minimize any impact to customers. But for specific configurations, and this is leveraging Azure dedicated hosts or the Azure full isolated instances, you have the ability to control when that maintenance is done on those instances. You'll get up to 35 days of a window to determine when to apply those updates. You'll get a notification when you query the machine that an update is available, and then you can either manually or now schedule when that patch is done. So the scheduled maintenance allows you to find a window when your application is, when you'd like your application to be updated, and then we will automatically, for those machines where you have for those instances where you have full control, apply the platform updates as well as the guest updates inside that defined window. And so this gives you much more control of when updates are done to the infrastructure layer, the parts that of running software that Microsoft Azure provides, or the software layer of your guest virtual machine. And as we go forward, we will continue to add into this maintenance control functionality to give you more control on when any kind of updates are being applied to both virtual machines and then later other services within Azure. Now let's talk a little bit about cost effectiveness. Now let me just recap. Spot Virtual Machines is a functionality that we released earlier this year. It allows you to get very, very high discounts on instances that leverage available capacity or slack capacity. So if we have capacity in the data center that's not being used by standard deployment machines, you can use that instance or that capacity for an instance and get it at around an 80% discount compared to normal standard deployments. Now, the caveat with that is If the capacity is needed for standard deployments, the instances will be evicted off of that capacity. And so that's the trade-off for very low cost, with the trade-off of the instances being evicted if the capacity is needed. Now, what we've added recently to make this easier is two things that we'll show in the example of here shortly. One is price history. And so you can see the price history or the trends that for the size that you've selected, as well as that size in related regions or nearby regions, as well as the eviction rate. And so this is the probability of machines of the virtual machine being evicted based on a past 28 days. And what this looks like, if you look here in the screenshot, you will see. So in this example, we've selected East US 2, and the size that's been selected is the DS3 V2. You see the bottom bar is the price history for the DS3 V2. Over time, you'll have a longer time frame to look at for the instances, but this is just recently released, and so it doesn't have as much history right now. But we also show you the price trends on the same VM size in other nearby regions. And so here it's showing East US and Canada Central as the two regions that are nearest the East US region. As well, at the bottom underneath each, you can see the eviction rate. And so you can see that in East US 2, the eviction rate's been quite low at 0 to 5%. But if you go into East US or Canada Central, for example, the eviction rate has been around 15 to 20%. And so from this configuration, you can see that the East US 2 is very likely the best place. It is the lowest price point for that same virtual machine, as well as the best eviction rate. But in some cases, there may be another region that is going to be a little bit better. So this gives you the flexibility to get more information about the spot instances so that you can deploy those and have lowest price points as well as the highest availability of those instances. Now let's look at some of the recent releases that we've had. First, we're going to look at the AMD series. So we've recently released the AMD DA v4 and EA v4 instances. The D series is 4 gigabytes of memory per vCPU, and the E is 8 gigabytes of memory per vCPU. And so these offer on the AMD EPYC-based processors for our kind of general purpose type workloads of D and E. Up to 672 megabytes of RAM in the E series, and up to 2.4 terabytes of local SSD temporary storage on these instances. We've also released the D and E version for our Intel offerings. And so specifically our Intel Cascade Lake-based systems, the D and E machines, again, 4 gigabytes and 8 gigabytes of memory per vCPU. And we've also added a difference here that allows you to lower your cost if you do not need the local disk. And so if you look at the D series, our DV4 versus our DDV4, in this case, the DDV4 contains local temporary disk that is very high performance, where the DV4, without the extra small case D here, does not include the local disk and will be available at a lower price point. And the same thing goes for the E and the ED V4 series, one with a local disk and one without. Again, allows you to customize the machine that you use based on the needs of that application. Moving on to our AI optimized and GPU optimized instances. The first one that I want to announce is the public preview of the NCV3 T4 instances. This is with the NVIDIA T4 deep learning accelerator. And so this is a great GPU-based machine for inferencing, video encoding, and some of the lighter GPU compute scenarios. For deep learning, we are now in a limited preview of our A100 NVIDIA offering, you can request access to this machine, and these will be rolling out as we go wider. This will offer effectively an AI supercomputer in the cloud, giving you up to 1.6 terabytes per second of memory of bandwidth per host. And then we continue to expand our hardware partners. In the GPU space, we've recently went into general availability for the NVA v4 instances. And this is with the AMD-based M125 GPU. And one of the things that's very unique and interesting on this configuration is we allow you to configure the GPU and actually slice it up. So you can, instead of having only a full GPU, which is the model for all other VM sizes, here you can have a half, quarter, or even eighth of a GPU. And this is very valuable for VDI type workloads where you're running a workstation in the cloud. You may not need the power of a massive number of GPUs that you might for GPU-based computing, but for a graphics workstation at an appropriate price point, this can be a great solution. And then finally, we have in public preview our first FPGA-based series, our NP series, that leverages the Xilinx FPGA. This allows you to build and debug your FPGA software on premises using your own FPGA hardware, and then you can seamlessly upload that to the cloud and run those. And so for certain workloads, this is a phenomenal performance improvement by leveraging the power of the field programmable gate array systems. Now, with virtual machine scale sets, we continue to add functionality that allows you to run the largest workloads on the planet within those systems. You can scale up to 1,000 virtual machines per zone, so up to 3,000 VMs across the zone, and you can easily deploy those and scale those using the Azure Resource Manager. Set of recently released functionality that we've added to the VM scale sets. The first is instance management. And this allows you to control which instances are removed when you scale down. You can configure to have either the most recently created instances or the oldest instances removed. And typically, depending on where you are in the software update cycle, we see a lot of customers switching between those two configurations. Next, you'll have instance notification. So when an instance is going to be removed because of a scale down operation, you can take action on that, clean up what maybe log files and things on those instances before the instance goes away. Third is what we call instance replace. And this is really nice functionality that allows you to, using a load balancer probe or using a direct health probe on the virtual machine, you can monitor the health of the machine. Now, Azure always monitors the health of the hardware. So if a power supply fails or disk fails, we're going to move the virtual machine to new hardware and let that run again. But if you have a problem in the software in the virtual machine, say you have a continual panic in the Linux kernel, or your software is hung up, something's not working. In this case, we will also detect that, and we will replace the instance automatically if you've configured this instance replace. So using the health system, if the application inside the virtual machine starts to fail, we will shut it down and replace it with a new instance. And then finally, we talked a little bit about the automatic OS updates. We've now expanded that to use custom images coming through the shared image gallery. And so this is just an example of leveraging the shared image gallery. You can take an image and distribute it worldwide in using the shared image gallery, replicate that to multiple regions, and then have the scale sets leveraging the shared image gallery to automatically update based on that image. Again, when you're doing an image-based update like this, the scale set will always retain the original operating system disk. In the event of a failure to update, let's say that you accidentally deploy an image that doesn't work for certain scenarios, the system will automatically detect that and will roll back to the previous version, set an alert, and allow you to deal with that. Again, the model is we want to give tons of control for you to maintain and keep your instances updated, but always do that in a very, very safe and availability first manner so that you always maintain very high availability for your applications. So today we've talked about several key innovations within the Azure Infrastructure as a Services workload. We've talked about dedicated hosts and how that expands to doing auto placement VMSS control. We've talked about VM patching and how that expands the ability to keep your instances secure. So you can use VM patching in addition to the existing model of image-based updating that's been available within Azure. Maintenance control, again, leverages and integrates with the OS patching as well as hardware updates and infrastructure updates within Azure, again, giving you more control on when updates are applied to your machine. And then finally, the eviction history and pricing history for Spot, giving you more control on when those instances are updated. And finally, I wanted to share a few links for additional capabilities and more information where you can find more information. The top one is a set of videos that we are producing that walk through specific operations, such as configuring and deploying a scale set and many other operations. And so I'd highly recommend checking out the Azure Compute channel. And then we have more information for all of the key functionality that we've talked about today in a very nice vanity URL that you can follow to get additional information. So thank you very much for watching the Ignite presentation for what's new and what's coming in Azure Compute. Thank you very much.